Hi everyone, welcome to the next lecture in our placement series. In this lecture, we will discuss about C++ STL. So what is STL? STL stands for Standard Template Library. So what it does, it contains some inbuilt functions which we can use to solve our problem. Okay, so there are so many inbuilt functions, there are so many inbuilt data structures that we will study about. Okay, so we will study about vector, we will study about pair, we will study about unordered map, ordered map, then unordered set, then what is stack, queue, priority queue. Okay, it provides us some algorithm. So it provides sort, swap, max, min. Okay, so these are the major ones which we use in our day-to-day life while coding. There are other data structures as well, like DQ, list, multi-set, multi-map. Okay, so STL provides a lot of DS. STL provides a lot of inbuilt functions and DS. But these are the major ones which we deal with in our day-to-day life. Okay, so we will study one by one about all of them. Okay, and at the end I will provide you the link of my notes which you can follow. Okay, so let's start with our first data structure, that is vector. Okay, so let's talk about vector. So what is vector? We have studied about array, right? So what is array? Array is a collection of similar data type elements. Okay, so array is a collection of similar data type elements, right? And what is vector? Vector is also the same, right? Vector is also a collection of similar data type elements. But what is the difference between vector and array? In array, so how we declare the array? What we write? We write int array and we give the size. Okay, or we just slice the elements. So we write something like this. Okay, so in array we declare the size. But in vector, we don't need to declare the size, right? We can write an array without passing the size. So where we can use vector, where we don't know how much size our vector will take, how much size we need to store the elements. Okay, so in that case, we can use vector. So vector is nothing but a dynamic size array. Okay, so how we declare the vector? We write vector and then our type. So it can be int, string, character, float, double, whatever type. Okay, so whatever type we have studied, we can write, and here we will pass the name. So it can be v1, v2, v3, v4, whatever name you want to give. Okay, so that's how we declare a vector. Okay, so what's its size? Its size will be initially 0, right? So initially it contains 0 elements. So how we can insert elements in the vector? So to insert element in the vector, what we can do? We use pushback. Okay, pushback is provided by STL only. So we use pushback. We will write the name of our vector and then we will use vector dot pushback whatever elements we want to put. Okay, see, we want to insert 1, 2, 3. So whatever element you want to insert, you can write inside the bracket. Okay, so that's how we do insertion in vector. Now, what if we want to delete the element from the end? So for that we have pop back. Okay, so how to delete the element from the vector? We use pop back. Okay, so we use vector name dot pop back, and we don't need to pass element, right? Because it delete elements from the end. So let's say we have 1, 2, 3 in our vector. So what it will do? If we write v1 dot pop back, it will remove this. If we write v1 dot pop back, it will remove 2. If we write v1 dot pop back, it will remove 1. Okay, so it will decrease count from end. Okay, so it will decrease count from end. So we have seen pushback, we have seen pop back. Pushback is used for inserting the element in the vector and pop back is used for deleting the element from the end. Okay, now to use vector inbuilt functions, we need to add vector header file. Okay, so hash include vector will include all the inbuilt functions of vector. Okay, so we can use pushback, we can use pop back. Now to find the size of our vector, we use inbuilt function size. Okay, so if we write v1 dot size, it will give us the size of our current vector. Okay, it will give us the size of our current vector. So after 3 pushback, after 3 pop back, what will be the size of our vector? It will be 0. Okay, so after 3 pushback, the size of vector will be 3. After 3 pop back, it will become to 0, right? Now there is one more inbuilt function that is called clear. So what clear does? It deletes all the element at once in the vector. Okay, let's say we have 1 2 3 4 5 6. So what pop back does? Pop back remove from one element from the end. Okay, so it will remove 6, then 5, then 4, then 3, then 2, then 1. Okay, so we need to write 6 times pop back to delete 6 elements. But clear, what clear does? Clear delete all the element at once. Okay, so we delete all the elements at once. So many times what we need to do, we want to reuse the same vector. So what we need to do, we need to delete all the elements from the vector and then initialize the vector again. Okay, so this was about size and clear. Now we have some more inbuilt functions. So we have begin, we have end. So let's say we have a vector 1 2 3 4. So begin is a iterator which points to our first index of our vector, and end is a iterator which points to next index of our last element. Okay, so end will point to here. Now if we want to use begin and end, what we can do, we can run a loop. So we will start a loop from begin and we will run until it reaches the end. Okay, so we will run our loop till here. Okay, that's why we are running it does not equals to end. So it equals to end will reach to here. Okay, so our iterator starts from here and it will run till here. Now, so what is it? It is our iterator. Okay, so it's point to every index in our vector. So I will start my iterator. Okay, if we don't know the data type of the element of our vector, so we use auto. Okay, so it will store the information of our current element. Okay, so it will start from begin and it will run until it reaches to end. Okay, so how we can retrieve the value of it? So we use star. Okay, iterator stores this information. Now to retrieve the information, we use star. Okay, we use star it. So star it will print 1, then star it will print 2, then star it will print 3, then star it will print 4. Okay, if we have 4 elements. So I have pushed 3 elements. Okay, 1 2 and 3. Now I will print using this iterator, using this for loop. Okay, so let's save this and run this. See, 1 2 3 is printed. Okay, this is for first loop and this is also another loop. So if I comment this and then run this, it will print 1 2 3. Okay, so that's how I can use this begin and end. So begin stores the information of first index, end stores the information of next to the last element. Okay, now there is one more way, okay, which we call for each loop. So we can print these values using for each loop also. Okay, so let's see them also. So this is our for each loop. In for each loop, what we do, we pass our vector and iterator will store the value of vector. Okay, so what it does, whatever will be the values in our vector, it will store it. Okay, so we can print using it. Okay, so it stores the value of our vector at each index. So it will go through the vector, let's say 1 2 3 4 5. So first it will store this, then it will store this, then it will store this, then this, and it will automatically end when it reach end. Okay, so no need to pass begin and end using for each loop. So not just in the case of vector, we can pass here map also, we can pass set also. Okay, that's the generalized format. Okay, so that's how we can simplify our for loop, that is our for each loop. Okay, now if we want to copy the value of one vector to another vector, what we can do, we can declare another vector. Okay, and what we can do, we can pass the previous vector, so it will copy all the values of vector v1 in v2. Okay, so let's say v1 contains 1 2 3 4 5. Okay, and if we write v1, it will store all the values 1 2 3 4 5 in v2. So v2 will also contain 1 2 3 4 5. Okay, now if we don't pass it initially, what we can do, we can declare a vector, like we can declare vector int v2, and then we can write v2 equals to v1. Okay, that's also correct. So that's how we can copy the values of one vector to another vector. Okay, now we know how to declare a vector. Okay, so what we do, we write vector, then our data type, okay, then write our name. Now if we want to pass the size initially, okay, so what I can do, I can declare it like this, vector int v1. If I want to create a vector v1 of size 5, so I can pass 5 here. Okay, so this will create a vector of size 5. Okay, no need to write this. So we can create a vector of size 5. Now if I want to pass the initial value, by default here, what will be the initial value? It will be 0. Okay, so what this command will do, it will create a vector of size 5. Okay, so 0 1 2 3 4, right? And initially it will store 0. Initially it will store 0. Okay, what if I want to initialize with some other values? So what I can do, I can declare a vector int v1. I will pass the size and I will pass the initial value. So I will pass, let's say 22. Okay, so if I first, this is the size of vector, this is the initial value at each index. Okay, so what it will do, it will create a vector of size 5, that is 0 1 2 3 4, and it will store 22 initially. Okay, so all the elements will contain 22. All the elements will have value 22. Okay, so we have seen how we can declare a vector, and we have seen how we can declare a vector with size, and how we can declare a vector with size and initial values. Okay, so let's write it somewhere. So that's how we can declare a vector without passing size. Now vector with size, so I can write vector int v5 with size 5. Okay, now if I want to pass the initial values, so what I can do, I can write vector int v6 of size 5 and initial value 22. Okay, so if I print this, let's say here I want to print the values of v6. So if I print this and run this, see, all the values are 22. Okay, so that's how we can create a vector with different parameters. Like we want to create a vector without size, with initial values. Okay, so I think it's clear about a 1D vector. So this is nothing but a 1D vector. Okay, one dimensional vector. So this is our 1D vector. Now how to create a 2D vector? We know how to create a 2D array, right? So how to create a 2D vector? In 2D array, how we write 2D array? So we write something like int arr, we pass the row size, we pass the column size. Okay, so that's how we can create an array with size 3 rows and 4 columns. Okay, so the same way we can declare a 2D vector. So in 2D vector, we pass row as m, we pass column as n. Okay, we can name whatever you want. So let's say I name m and n. Okay, in 1D array, what we write? We write vector, and inside vector we pass the data type, right? But in 2D vector, what we will do? We will pass a vector inside vector, right? So how we can write this? In 1D array, we write vector, okay, data type, and then its name, right? In 2D array, what we will do? We will write vector, and inside int, what we will do? We will again write a vector int Okay, so this is another vector, right? This is another vector. So we are passing vector inside vector. So this will be nothing our 2D vector. Okay, let's say I name it as v2. Okay, so that's how you declare a 2D vector. So we can declare a 2D vector like vector and vector. Inside it we can declare a 1D vector. Okay, so like v8. Okay, so that's how we can declare a 2D vector. But what if we want to pass the size and initial value to it? So what we will do, we will pass the number of rows and then the number of columns and the initial value in this format. Okay, so what we will do, we will pass number of rows. Okay, then again how we declare 1D array. Okay, so here again I will write the code for 1D array. Okay, that is nothing but 1D array, and inside it what will be the number of columns. Okay, and what will the initial value. So that is our initial value. Okay, so initially all the elements will have -1 -1 -1 like this. So first we declare our 2D vector, then here we will initialize it. Okay, we'll pass the number of rows, the number of columns and the initial value. Okay, so how we declare a 1D array? We will declare like this. Okay, this is 1, let's say 2, let's say 3. Okay, and in 2D array, how we will declare 2D array? You can visualize 2D vector like this. Okay, so this completely is our 1D vector, right? And in 1D vector we are creating another vector. Okay, so this 1D vector have size, let's say m. So this 1D vector is of size m, right? And inside it we have another vector of size n. Okay, so m is nothing but number of rows and n is nothing but number of columns. Now to initialize the value, what we want to do, we want to go inside our 1D vector, right? So in 1D vector we have another vector. Okay, so to initialize the value, what we have to do, we have to go inside this, right? So how we initialize the value? First we will go inside our rows, m rows, and inside our m rows we will have vector, right? And we will initialize the values of row, of column, and with -1. Okay, here inside our 1D vector, how we initialize the vector? That's how we will initialize it. Okay, so that's how we will initialize the values, right? So we will declare 1D vector inside our 1D vector, and this is nothing but how we declare our 1D vector with initial values. Okay, so if you identify the pattern, it is nothing but we have vector. Okay, then we have another vector, right? Then we will give the name of the vector. Okay, then we'll pass number of rows, then we will initialize the values of vectors. Okay, initialize the values of inside vector. Okay, so that's how we declare a 2D vector, right? Now if we want to change the value, so what we will do, we write v3, and let's say I want to change 0th row, 4th, 5th column value. Okay, so I can write like this, same as array, right? And all the operations we have seen in 1D vector, push back, pop back, clear, erase, size, begin, and that's all applicable on 2D vector as well. Okay, so that's how we declare 2D vector. Now let's see 3D vector. So this is our 3D vector. This is a bit complex, but we will use 3D vectors in our DP problems. Okay, so in DP we use 2D, 3D vector most frequently. So in 3D vector, we need 3 dimensions. Okay. So we need X, we need Y, we need Z. So these are 3 dimensions. In 3D vector, what we will do? We will take another vector, right? So in 1D vector, we will take another vector, and then we will take another vector. Okay. So first 1D vector, then inside it 2D vector, then inside it 3D vector. Okay. So I can write something like vector, then inside it another vector, then inside it another vector. That's how we declare it, right? So 1D vector, then 2D, then 3D. Okay. Now I will write the name of the vector. Then I will write our first vector. Okay. First vector dimensions. So I will write here. So here I will write same as in the 2D vector. Okay. So how will write 3D vector? So in vector, we will write same as 2D vector declaration. Okay. Now I will pass the name. I will pass the dimensions of outside vector, and here I will declare and initialize the 2D vector. Okay, not basically declare, but how we declare and initialize the 2D vector. That's how we will write it here. Okay, so you can identify the pattern, right? Otherwise it will be very difficult. So for 2D vector, we write this. Okay, another vector, and then initialize the 1D vector. Okay, so that's how we declare the 3D vector. Okay, if you don't remember it, that's okay. We will see. The more we will keep on doing, the more we will practice. Okay, so these are the basic operations which we perform in the vector. Okay, there are a lot of inbuilt functions, but we don't need them all, right? The more generic, we use pushback, pop back, begin, end, size. These will be used in our further programs. Okay, so this was all about vector. Let's move forward to the next DS. So let's see what is pair. Pair generally holds 2 values, right? So one can be of any data type, another can be of any data type, and everywhere whenever we access the pair, it can have 2 values, right? So it can have integer type value, it can have any data type value. Okay, so both the values can be of any data type, right? So let's say we have a pair 2, 3, right? So if we want to access this value, the first value, we can write pair name. Let's say our pair is p1 dot first, and if we want to access the second value, then we can write p1 dot second. Okay, so p1 dot first will give you the first value, and p1 dot second will give you the second value. Okay, and it can be of any data type. So here we have taken a integer and a character value in our pair. Okay, so in the curly braces, we write the pairs. Okay, so here we are initializing the pair. Pair p1 holds the value 10 in the first and k in the second. So k is of type character, right? And we can access using p1 dot first and p1 dot second. So anything which contains 2 values, we access using first and second. Okay, so now there is one more way to write pair. Okay, so here we have declared and then initialized, but what if I want to declare and initialize in the same line? So that here we can declare and then initialize the values here only. Okay, so it will be same as writing p2 equals to 1 comma n. Okay, now there is one more inbuilt function. By using, we can make a pair. Okay, so we have make pair also, right? So make pair is also used to initialize the values. So if you want to put some value in p3, we can initialize by using make pair. Okay, so make pair will hold the values. So make pair will take 2 values, right? So first will be of first data type and second will be of second data type. So these are the ways how we can declare and initialize the pair. And we have seen some inbuilt function like size, begin, end, empty. So pair also follows them, right? Okay, so this was about pair. Now what if you want to hold three values, right? So what if I want to hold value something like 1 comma 2 comma 3? Okay, if I want to hold value like this, so can I do it using pair? We can do it using pair, right? So what we can do, we can take one pair of this one and another pair of these two values. Okay, so one pair will contain this as first and the whole as second. Okay, now if I want to access one, so what I can do, I can write, let's say my p1 is a pair name, so I can write p1 dot first. So p1 dot first will give you 1. Okay, and if I want to access second, so what I will do, I will write p1. Okay, then we'll go to the second, so dot second. Then I want to access the first of second, so then I can write dot first. So it will give us what? 2, right? Now if I want to access 3, so what I can do, I can write p1 dot second dot second. Okay, so here it will give you 3, right? So we can make pair of pair, vector of pair, multiple pairs. Okay, we can use anywhere, right? Whenever you want to take two values, you can use pair. Okay, so how we can declare a pair of pair? We can declare it like pair, and then inside it we were declaring two values. So if you want to declare like this, in this form, so my first value will be of integer type, and the whole is a pair, so we'll again take a pair. Okay, we'll again take a pair of, let's say, int comma int, right? So this will be of same kind. So it will first will take an integer value, and second is again a pair, so it store values in this form. Now what if I want to store values like this will be a complete pair and this will be a pair of these values? So if I want to store this in a form of pair, so what I can do, I will take this as a pair and this as our data type int, and the whole this one, the whole will be a pair. Okay, so it will be a pair of int comma int data type, right? So we can write it like pair of, this will be a pair of int comma int, and this will be of integer data type. So this is the second value, this whole is a first value, and this will be a second value, so it will be of type, let's say, int. Okay, and its name is, let's say, p1, right? So if I want to access 1, so what I will write, I will write p1 dot first. So p1 dot first will give me access to this, it will be equals to 1, right? If I want to access 2, so how I will write, I will write p1 dot first dot second, it will give us the access of 2. Okay, so it will be 2. Now what if I want to access 3, so I will write p1 dot second, and that will give us 3. Why? Because it stores the single value as int. Okay, and the first stores a pair, so if anywhere it will be a pair, so we will access using first and second. Okay, so it was about pair. Now can I use vectors with pairs? Yes. So in usually what we do in vector, we write vector int v. Okay, so it stores the values of integer data type. So let's say this is a vector and this stores integer type values, right? But if we take vectors with pair, what will store? It will store a pair. It will store a pair. Okay, So every index will have two values, right? So this will be 0 index, first index, 2 index, and this is a pair. This it will store the pair. Okay, so this is nothing but vectors with pair. Now if I do v dot pushback 5 comma 7, so what will be happen? 5 comma 7 will be stored here. If I do v dot pushback 9 comma 10, okay, so I will push 9 and 10 here. Let's say I again push 10 comma 12, so it will hold 10 comma 12. Okay, so this is a pair. So instead of using int, I will write here a pair. So I know how we declare a pair. So instead of int, I will write pair of int comma int, whatever data type we want to take. Okay, so incompletely, what I will write? I will write vector of pair of int comma int. Okay, to store integer values. So let's name it as v. Okay, so v at 0, it stores what? It stores two values. Basically it stores a pair. Okay, it stores a pair. So if I want to access the first value of 0th index, what I will do? I will write v0 dot first, right? v0 dot second, to store the second value at 0th index. Okay, so it will give us 5, it will give us 7. Now if I want to access the value at first index, what I will write? Let's delete it. So if I want to access the values at first index, so what I will write? I will write v1 dot first, it will give us 9, and v1 dot second, it will give us 10, right? Similarly, if we want to access the values at index 2, so I can write v2 dot first, v2 dot second. Okay, so that's how we can store vectors with pairs. Okay, now how to iterate them? Okay, we have seen this in vector, right? So we can iterate using our for each loop or using our normal for loop with the help of begin and end. Okay, so it will start from first index and it will go until the vector is not empty, right? So my end will be here and it will run till here. Okay, so we are iterating, we know these things, we know, right? So this was about pair. Pair is very simple, right? It holds two values. So we can use pair in anywhere, right? We can use in vector, we can use in queue, we can use in stack. Whenever we require two values, okay, whenever we require two values somewhere, so we can use pair, right? So this was about pairs. Now let's see another data structure. So our next data structure is unordered set. Okay, so to use unordered set, we include unordered set, hash include unordered set, right? So what is set? So let's say we have some values, let's say 1, 2, 3, 4, 4, 7, 9, 9. Okay, let's say we have some values. Now there are some repeated values. 4 is repeated 2 times, 9 is repeated 2 times. Okay, what if I want to store only unique elements? What if I want to store only unique elements? So there I can use unordered set. Okay, there I can use set. So in unordered set, what will happen? Let's say I store these values in unordered set. So what will happen? It will store 1, 2, 3, 4, 7, 9. Okay, so it will store all the elements only one time. It will not repeat the elements, right? So repetition will not be there in set. Set stores only unique elements. It holds only unique elements, right? So many times set and maps are very helpful. So whenever we need this property that we need only unique elements, so we can use set, right? So what is unordered set now? So the set stores only unique elements, right? Now what is there in unordered set? So in unordered set, it will store unique elements but in random order. Okay, so it is not necessarily true, right? It can store something like 3, 4, 7, 9, 1, 2, right? it can store 1, 2, 7, 9, 3, 4. Okay, so in any order it can hold the values. Okay, now why we use unordered set? Because the time complexity of inserting the elements in unordered set is order of 1. In order of 1 we can insert one element in unordered set. Okay, so here we have declared one unordered set and we are storing these values. So it will store 10, 20, 30 and 40. Okay, no matter how many times an element occurs, it will store only once. Okay, so this is the one way, right? Now if I want to copy these values in another set, so what I can do, I can simply declare another set and equals to that previous set. Okay, so this will hold the values of natural number set. So S2 will contain all the values of natural numbers, right, in unique order. So this is the second way. Okay, now this will do the same way. Okay, in S3 I am storing all the elements of natural numbers, right? So this is the third way. Now this is the fourth way. There is one more way. Okay, so we can write natural numbers dot begin to natural numbers dot end. Okay, so from where to where I want to copy the elements in our set. Okay, so this is the way I can copy the elements of one set to another set, right? Now let's see how we do insertion in set. Okay, so we use this inbuilt function insert. Right? So I will write set name dot insert and whatever value I want to insert, right? The first way is I can initialize all the values in our set at the time of declaration, or what I can do, I can insert one by one. So if I want to insert 1, I can write dot insert 1, I can write dot insert 2, right? So I can write dot insert 3, right? So here I will write my set name. So insert is our inbuilt function in our unordered set and set header file. Okay, so how we insert in the set? By using insert inbuilt function. Okay, insert inbuilt function. So one by one I can store all the values in a set. Now how to delete the value in set? So we can simply write dot erase, right? We have seen this in vector. So if I want to delete one value, so I can delete it. Okay, so this will delete 4 from our set. Let's say our set contain 1, 2, 3, 5. Okay, this is the set named natural numbers. So this is our set. Now if I want to delete 4, what I can write? I can write my set name dot erase whatever I want to delete. Let's say I want to delete 3, so I can write 3. So it will delete 3 from my set. Okay, if I want to delete 4, so I can write dot 4. If I want to delete 5, I can write 5. Okay, so dot insert to insert the element in the set and dot erase to delete the element from the set. Okay, now in set, one of the interesting thing is find. Okay, one of the most important and interesting thing is find. So in many times what we will do, we will store some values in set and then we will find whether it is present in set or not. Okay, so to find a value in set, we have dot find function. So if I want to find something in our set, what I can write? I can write dot find until my end. Okay, so what it will do, it will traverse in my set and find whether 2 is present or not. Okay, so we know this will run till my last index. Okay, my last value in the set. So it will take care of that. I will traverse whole set, right? So if I found, this means that I have found the value 2 in our set. If this condition satisfied, then it means that 2 is present in our set. Okay, and if that condition falls, then 2 is not present in our set. Okay, so please take care about this condition. Okay, this will not equals to this, right? We will not write this. What if we write this? What if we write find 2 equals to natural numbers dot end? So if this condition satisfied, then what will happen? It means that 2 is not in our set, right? because this says that it checks till the end, right? So this says that it comes to end. It comes to end. That means if 2 is not found in our set, that's why it comes to end, right? So if it comes anywhere in the middle, it will not comes to end. That's why I'm writing not equals to. That means it find the 2 in our set. Okay. So please take care of this not equals to, right? Because it should not go till the end, right? If it's there, if 2 is there, it will not go till the end. If it go till the end, that means 2 is not there, right? So find is very important in set and in map also. We use find a lot of times. Now there is one more inbuilt function, that is count. So what count does? It returns whether the element is present in our set or not. Okay, so if I write this dot count, so it will check whether 5 is there in our set or not. So if it's there in our set, then it will return true, otherwise it will return false. Okay, so count is also there, so we can write find and count for finding our element, right? So we can write find and count for our finding our element. So we can find using count also. Okay, so count will return true if it's there. If it's not there, it will return false. Okay, and that's how we can traverse it. Okay, whether it is map or set or vector, we can traverse it like this. Okay, now we have 10, 20, 30, 40. So let's run this. Let's see what's present there. See, we have inserted 10, 20, 30, 40, and then we have inserted 1, 2, 3, 4, 5. Now we have deleted 4. Okay, so my set contains 10, 20, 30, 40, and then 1, 2, 3, 5. So see, 1, 2, 3, 5, 10, 20, 30, 40. It is there in the set, but it can be in any order because we are using unordered set. Okay, so we are using unordered set, that's why it can be in any order. What if I use set? Let's remove this. Okay, so I'm using set. Now let's comment this. If I use set instead of unordered set, so what it does, it also stores unique elements but in the sorted order. Okay, so let's see, 1, 2, 3, 5, 10, 20, 30, 40. Okay, so it stores in the sorted order. That's why the time complexity of insertion of each element is log n in case of set. Okay, so in case of set, every insertion takes log n times, right? So unordered set, ordered set, both have same property. The only property changes is the sorting property, right? It also stores unique elements. So now let's see this. Now let's find whether 2 is present or not. Okay, so 2 is present in our set, so it should return this, 2 is present in set. Let's run this. See, 2 is present in set. Okay, so if you write equals to, then it will go inside if only when it doesn't find 2 in our set. Okay, so if you write this, then if it will go when you find the element in the set. Okay, so don't get confused. Now let's print this count also. So let's say I print this count. Okay, so what it contains, let's print this. See, it is printing 1. That means 5 is there in the set. Okay, yeah, 5 is there in the set. 4 is not there in the set. So let's count 4. See, it is printing 0. Why? Because 4 is not there. So it will print 1 when the element is there. It will print 0 when the element is not there. Okay. So this was about set, and in set we can use insert, erase, find, and we can use other STL as well, right? We can use begin, end, we can use erase, we can use find, we can use size, right? So whatever we have discussed in vectors, almost we can use everything in set also. Okay, now come to the next DS. So our next is map. Okay, so let's discuss map. So we have unordered map and we have map. So to use unordered map, we need to include unordered map header file. And to use map, we need to use map header file. Okay. Now, what is map? So map is a data structure which stores information in key value pair. Map stores information in key value pair. So key can be of any data type, value can be of any data type. And let's take an example. So let's say I've taken an unordered map, okay, and named it as UMap. So let's take a unordered map, name as UMap, and it will store information in key value pair. So this is our key and this will be our value, right? Now I will insert, how I can insert values in map. Let's see. So I will write the map name and I will write here the key, in which key I want to insert the value, and I will write here the value. So my map is of type integer and a string, and I will write key as an integer data type and I will write values in a string data type. So let's write it here, 9 key corresponding to value Deepak. Now I want to insert key 3 and I want to pass value as RJ. So for key 3 the value is RJ. Similarly insert this also. For key 4 I am inserting Dheeraj. For key 5 I am inserting Aman. Okay, and for key 6 let's insert here, I am inserting Priyanshu. Okay, so that's how we insert value in map. Okay, now let's see how we can delete value from map. So to delete the value from map, we use erase. Okay, so umap.erase, I will pass key here. So let's say I write umap.erase 5. So 5 is here. So it will delete 5, Aman entry. Okay, so 5 is our key and Aman is our value. So when we write erase, so it deletes this entry. This whole is a one entry, right? So if I want to delete the entry of key value 4, so I can write erase 4 and it will delete this entry. Okay, so similarly I can pass any key and the entry corresponding to that key will be deleted, right? So that's how we do deletion in map. Now there are some more inbuilt functions in map, so we can use those also. So one of the most used function is find. Okay, so how to find values in map? So we have inbuilt function called find. Now in map whatever manipulations we do using key. So key is the unique thing. Okay, so we do any operations using key. We are inserting using key, we are deleting using key, we are finding using key. Okay, now if I want to find whether 3 is there or not, and if 3 is there, I will print the value corresponding to 3. So I will write umap.find 3 and I will check till end. Okay, so it will check from here till here. Okay, so it will check. Now if it finds 3 in the map, if it finds the key 3 in the map, then what it will do? It will print. So value of 3 is umap of 3. Okay, so umap of 3 is here. Umap of 3 will print the value corresponding to key 3. So key 3 has the value RJ. So it will print value of 3 is RJ. Okay, and if it is not there, let's write it 3 here. So if it is not there, we'll print 3 is not a valid key. Okay, or 3 is not in our map. Because if 3 is not there in our map, then what we will do? We will simply print that 3 is not there. Okay, 3 is not a valid key, right? Similarly, let's say if I want to find the key 100. So if I check key 100 is there in our map or not, so it will check till end. Okay, so 100 is there, no, 100 is there, no, 100 is there, no. So 100 is not there. So key 100 is not there in our map. So what it will write? It will print 100 is not a valid key. Okay, so that's how we find the key in our map. Now finding operation is very efficient in the map. So it takes almost order of 1 time. In majority cases, it takes order of 1 time. In some cases, it may take order of n, right? When there is a huge collision. So we will see it in the map internals. Okay, But for now, understand that majority of the times finding operation takes order of 1 time, right? So this is the find operation. In map and in set, we use find operations very frequently. Okay, now let's see some more functions. There is one more way to check whether the key is present in our map or not. So we can use dot count function, right? So dot count function, what it does, it returns the boolean value. If let's say 18 is our key, so we pass the key, right? In map we pass key everywhere. So if we pass the key 18 is there in our umap? No. So it will return 0. 0 means false, it is not there. Okay, now if it is present, let's say I check, I write key as 3, so it will return 1 because it is there, in our umap. So is present will store 1, okay, for key 3. So if I want to find whether the key is there or not, we can use count or we can use find. Okay, now how to iterate in the map? So it's very simple. We can write umap name here, okay, and then it dot first. Okay, we have two things here, key and value. So it dot first will print our key and it dot second will print our value. Okay, so we have seen this in pair also. So whenever there will be two things here, so I will write dot first and dot second. Okay, so in map I will write it dot first and it dot second. So first it will return 9 and then space and then debug. Okay, so it will print whole map keys and values. So 3 RJ, 4 Dheeraj, right? So it will print all the values in map. So that's how we iterate in map. Now let's see what is the difference between unordered map and map. So both are same, both are almost same, and the functions are almost same. The only difference is in unordered map, the ordering is not maintained. Ordering is not maintained. Okay, what does it means? It means that it cannot be the same case that I have inserted 9, then 3, then 4, then 5, then 6. Okay, so it cannot be the case that every time it will store in same sequence. Okay, so let's say 9 Dheeraj can be stored in the last. Okay, it can be stored in the middle, it can be stored in the second place. So the elements can be stored in any order. Okay, so that's why unordered map is taking less time. So every insertion in unordered map, every insertion takes almost order of 1 time. Okay, every insertion takes almost order of 1 time. In few cases it takes order of n times, but we consider in most of the cases it takes order of 1 time, right? Now in map, if we take map, okay, if I take this map here, so in map order is maintained. Okay, so what order I'm talking about? I'm talking about sorting order. Okay, I'm talking about sorting order. So in ordered map, what will happen? It will store 3 RJ first, okay, then 4 Dheeraj, then 5, then 6, then 9. So the keys will be in sorted order. In map, the keys will be in sorted order, okay, and corresponding values will be same, right? So in map, the order is maintained in sorted order, okay, and in unordered map, it can be in any order, randomly order will be assigned. So that's why the time complexity of insertion in map is log n, and in unordered map is order of 1. Okay, now where we can use map and where we can use unordered map. Okay, so the first thing is wherever you can use unordered map, you can use map, but you need to take care of time complexity. So insertion in map is costly, it is order of log n, right? But in unordered map it is considered as order of 1. Okay, so unordered map insertion is taking less time than map. Now where we can use unordered map, where the sorting order is not required. Okay, so 1, 2, 3, 4, 5, these keys in sorted order is not required, so we can use unordered map. But where order is required, then we have to use map. Okay, So in many places we need the order to be in sorted order. So there we can use map. Okay, if order is not required, we can use unordered map. That's the only difference between map and unordered map. Okay, so we have discussed few functions of map, how we can declare map, how we can initialize map, how we can delete values in map, okay, how we can find values in map, and how to iterate map. So this is all about map. Let's move forward to next data structure. Now let's discuss what is stack. So stack is a data structure which stores information in LIFO order. Okay, LIFO. So what is LIFO? LIFO means last in, first out. So what does it means? Last in, first out. See, in many places you go first, but you came last. Now, if you see a very basic example, in a marriage or in a function, there are a lot of plates. Okay, there are a lots of plates. So the plate which we put it first will use in the last. Okay, will use in the last. So there's a bunch of plates. Okay, there's a lot of plates, one above another. So can we use the last plate directly? No, right? So we will start from top. Okay, so we will start picking from top, and then one by one we will come to the last one. So the plate which was put it in the first, it will come in the last. Okay, so that's how stack data structure works. Now we have data structure stack. Okay, so let's say I want to insert A, B, C. Now if you want to print CBA, what you can do? You can put it in a stack. Okay, so first put A, then put B, then put C, and when you start popping, so C will come first, then B will come, then A will come. Okay, so that's the one application. Okay, we can use a stack for reversing the string. So there can be a lot of use cases of stack. So this is one of them, right? So why we are using a stack. Now there are some operations which we perform in a stack. Okay, so how to insert in a stack, how to delete from a stack. Okay, and in a stack we have seen this is the structure of a stack. So how we insert in a stack? We use this inbuilt function, that is push, which is given by the stack header file. Okay, so this is our header file, and it will give us the function push. So let's push 0. Okay, then push 1, then push 2, then push 3, then push 4. Okay, so stack have one end which we call as top end. Okay, so this is the top. Okay, this is the top. So we can extract element from top only. Okay, that's why LIFO property fulfills, right? So we can put it first and it will come in the last. Now we know how to insert in the stack. Okay, we can use push. How to delete element from the stack? So if I want to delete one, from the stack, can I do this? No, because stack doesn't allow us to delete any random element. Okay, it only allows us to delete the element or to extract the element from the top. So we can delete 4 only. Okay, at a time we can delete 4 only. Now how we can do this? So to delete the element from the stack, we use pop. Okay, so we use pop. Push is there in stack, pop is there in stack. So what pop will do? It will remove this 4 from the stack. In one time pop, it will pop out 4 from the stack. Okay, if I another write st.pop, it will again pop 3. If I again write st.pop, it will delete 2. If I again write st.pop, it will delete 1. Then similarly delete 0. Okay, so for each deletion I need to write st.pop. Okay, now if I don't want to delete, I only want to check what is there in the top. Okay, so what is there in the top? So I can write st.top. So top is also inbuilt function provided by a stack. Okay, so in a stack we generally have push, pop, top, and empty. Okay, these all are functions. These all are functions. So generally these functions are used. Okay, so push to insert the element, pop to delete the element from the top. That's very important. Okay, we cannot delete any random element in the stack. We can only delete the top element. Okay, now how to find the top element? We can use this top. Okay, now we can use some inbuilt function which we have discussed earlier. We can use size, we can use empty. Okay, we can use begin, we can use end. So next is the empty. Okay, so why we use empty? To check whether the stack is empty or not. So it will return 1 if stack is empty. It will return 0 if stack is not empty. Okay, so these four functions are there majorly for stack. Okay, so let's say I have inserted 0 1 2 3 4. Okay, and then I have popped out 4 from the stack. So now stack contains 0 1 2 3. Okay, now if I want to print all the values in stack, how can I print this? So first I will find the top. Okay, and then do a pop so that next element will come to the top. Okay, so first what will be there? First 3 will be there, then we pop out 3. So 2 will be there, then we pop out 2. Then 1 will be there, so we'll pop out 1. Then 0 will be there, so we'll pop out 0. Okay, and we will run this loop until our stack it becomes empty. Okay, so see, we have used empty, we have used top, we have used pop. Okay, now let's run this. See, we have 3, then 2, then 1, then 0. So why it is printing in the reverse order? Because stack has the property of LIFO, last in first out. Okay, so 3 came last. Okay, then 2, then 1, then 0. So 0 came earlier, so that's why 0 is printing in the last. So these all are the operations of stack, and it's very easy, right? So how to declare a stack? We use stack and then our data type and then whatever name you want to write. Okay, so generally I use st for stack, I use s for set, I use umap for unordered map. So you use consistent naming conventions. Okay, so that when you see here st.pop, you don't need to check what is st, right? So use consistent naming conventions. That will help you to understand the naming convention, and it will help your subconscious mind. So every time whenever you see st, you will understand that it is stack. Okay, so this was all about stack. Let's see queue. Now what is queue? So let's see. So in stack has the property of LIFO, right? Queue has the property of FIFO. Okay, what does it mean? It means that first in, first out. First in, first out. Okay, so let's see how it works. So this is generally we write queue as like this. Okay, so this is our queue. We write stack like this. This is our stack. Why? Because stack have only one end, that is top end. Okay, queue have both ends. Queue have two ends. So this is called front end. Okay, and this is called rear end. Right? So this is the structure of queue. So we have this front end, we have this rear end. Now why two end? Okay, so let's see this. Now how to insert and delete in queue? Okay, so we have seen push, pop, empty, top in stack. Okay, so similarly in queue also we use push, pop, empty, but in stack we had only one end, that's why we were using top. But here we have two ends, that is front and rear. So how to access this front? So we have something called as front in queue. Okay, so let's insert values in queue. So let's say I want to insert 1, so I will insert 1. Let's say I want to insert 2, so I will insert 2. Let's say I want to insert 3, so I will insert 3. let's say I want to insert 4, so let's write 4. Let's say I want to insert 5, so let's write 5. Okay, so that's how our queue will look like after inserting 5 elements. Now I want to delete elements from queue. So it holds the property of FIFO, right? First in, first out. So if I want to delete, which element should be deleted? 1 or 5? Which element should be deleted? 1 or 5? Obviously 1, right? Obviously 1, because we have inserted 1 first. Okay. So how we can delete 1? How we can delete 1? So we have pop. Okay, we have pop. So in stack we had pop. Similarly, we have pop in queue also. So queue dot pop, it will automatically delete this first element from the queue. Now if I again perform pop, so it will again delete this. Now if I again perform pop, so it will again delete this. Now if I again perform pop, it will again delete this. Okay, so that's how we can insert and delete. Similarly as a stack. Okay, so this queue will take care how to push and pop in the queue. Okay, now let's say we have these 5 elements in the queue. Okay, so how to find the front? How to find the front? So we have something called as front method. Okay, so this will give you the front of the queue. So why we use this? Let's say I want to store values in queue and I want to iterate values in the same manner. I have inserted 1 2 3 4 5 and I want to iterate in 1 2 3 4 5 manner. So what I will do, I will iterate through the queue. Okay, and how I will iterate, let's see this. So queue dot front will give me the front element. Okay, and similarly we have queue dot empty, so it will check whether it is empty or not. Okay, it is common for all the functions. It is common for all the data structures, right? So empty and size is common for all the data structures. Now I want to iterate through the queue. Okay, so that's the interesting thing. So first we will check whether queue is empty or not. Okay, if it is not empty, then how to print the values? I will write queue dot front, so it will give me the 1. Okay, it will give me 1. Now I will pop this out. Okay, so that I can iterate through the next value. So if I delete this will be our front, right? Let's erase the remaining thing. So after erasing 1, we have 2 in the front. Okay, now pop this also. So if I'm popping this, then my front will shift to here. So this will be my front. Okay, now print this value. So front function will give me 3. Okay, now again pop, then again go to next. So it will give you 4, then again pop, then again front will give you 5, then again pop. Okay, and after this it will be empty. Okay, so it will come out of this loop. So that's how we iterate the queue. Okay, so similarly stack, in stack we had top, in queue we have front. Okay, almost everything is same. So if you want to read about the time complexity of all the operations, I have written the notes. Okay, so in notes time complexity of every operation is given, so you can refer the notes. So this was all about queue. Now move forward to next data structure. So next we have priority queue. Okay, so what is priority queue basically? So we have already studied about heap, right? In heap sort we have already studied about heap. So priority queue is nothing but the STL for using heap. Okay, STL for by default using heap. So in heap sort, what we used to do, we used to build heap, right? We used to build heap, whether it can be max heap or it can be min heap. So we used to insert the element in heap, right? So that's work can be done by using priority queue. Okay, no need to write the whole code for build heap. We can use priority queue. So priority queue will insert the element in the heap order. So by default it holds the property of max heap. Okay, by default it holds the property of max heap. What does it mean? It means that at every level the value of parent will be greater than both of its child. Okay, the value of parent will be greater than both of its child at every level. So if you want to read more about heap, you can go and check out my previous lecture on sort. Okay, so in sorting I have talked about heap sort. There we have discussed in detail what is heap, how to create heap. Okay, so I am not teaching this in this lecture. Now how to declare a heap? So we use priority queue. We use priority queue, and here inside this, see inside this, in every STL register we write data type inside this. Okay, so what is our data type? So here I am writing int. So that means that our heap is of data type int. It stores the integer data types values. Okay, so I named it as PQ. PQ means priority queue. Okay, so how to insert in priority queue? See, we have studied about push and pop. So similarly, like stack and queue, we use push to insert in the priority queue, and we use pop to delete from the priority queue. Now in priority queue we have top. Okay, we have top function. So what top give? See, in priority queue what happens that, let's say this is 10, this is 5, this is 6. Okay, so the parent will be the largest element. Okay, the parent will be the largest element. So it will give you the top. That means it will give you the maximum element. So if you do pq.top, it will give you the top element, that is 10. Okay, now if you pop, let's say I pop 10, so what it will store? It will store something like this. So this will be our top. Okay, now pq.top will give you the top element. Okay, so this will be the largest element in 5 and 6. Okay, so in any problem where we use this priority queue, so let's say you got the problem that find kth smallest, okay, or kth largest. So whenever you see this kth smallest or kth largest, just try to understand that we can use priority queue. How? See, if I want to find kth largest element, what I can do? I can pop this k minus 1 times, right? I can draw a max heap and I can pop k minus 1 time. The top will give you the first largest. Okay, if I pop 1 time, it will give you second largest. If I pop 2 times, it will give you third largest. Okay, so the top every time the top will give you the largest element in the containing elements. Okay, so we use pq.top to find the top element. Okay, so in max heap it will be the maximum element. In min heap the top will give you the minimum element. Okay, so next we have pq.empty. So empty we have studied to check whether it is empty or not. Okay, now how to iterate the priority queue? So it is similar way as stack. So in stack we use pq.top. Okay, so in priority queue also we have only one end, so we use pq.top. So this is same as stack. Okay, we know how to iterate it. Okay, first every time find the top and pop it out, so that next element will be at top. So then it will again pop out, then next element will be the top. Okay, so that's how we iterate in priority queue. Okay, similarly as stack. So priority queue by default stores max heap. What if we want to use priority queue as min heap? Can we do that? I want to use priority queue as min heap. Can I do that? So STL also provides the functionality to use priority queue as min heap. How? Let's see. So using this you can use priority queue as min heap. Okay, what do you need to do? You need to write priority queue. Let's raise it. So what you need to do? You need to write priority queue, then int, vector int, greater int, min heap. Okay, so this will enclose in this one. So inside this you need to write int, comma, vector int, comma, greater int. Okay, that's the syntax of min heap, right? That's the syntax of min heap. So now in min heap you want to insert 8, then 10, then 1, then 4, then 6, then 18. So what it will do? Every time your parent will be less than your child. Okay, both the childs. So in min heap, every time your parent, at every level your parent will be less than your all the childs, your both childs. Okay, so it was about min heap and max heap. Now let's run this code. Let's run this. See, I have inserted 1, 2, 3, 4. Now I have done the pop. So pop will delete the maximum element. Okay, so it will delete 4. Now what will be at top? 3 will come to top. Okay, so 2 will be the left child of 3 and 1 will be the right child of 3. Okay, now even if I insert 1 here and 4 here, let's say I insert 4 here, then also it will give the same result. Okay, because it is deleting the maximum element from the priority queue. Okay, now, okay, similar way we can use min heap. Okay, so this will use priority queue as min heap. So in min heap I will store 8, 10, 1, 4, 6, 18. So now, and I am popping it out, so it will remove the minimum element. So out of all these, the minimum element is 1. So 1 will not be there in our min heap. So let's run this. See, 1 is not there. Okay, and 4 is our minimum element, so it will be at top. Now 6 will be the left child of 4 and 8 will be the right child of 4. So after this, 10 will be the left child of 6 and 18 will be the right child of 6. Okay, so at every level the parent is less than the child's. Okay, so that's how we use min heap. So it was all about max heap and min heap and how we can use it using priority queue. Okay, so we don't need to, let's say if I am writing heap sort, now we don't need to create the heap. Okay, so this was all about heap. Now let's move forward. So till now we have seen some data structures. We have seen stack, we have seen queue, we have seen priority queue, we have seen map, we have seen set. Okay, now there are some inbuilt functions under the algorithm file. Okay, so that give us some functions which we can use. Let's say if I want to sort the array, so till now we were writing the huge code for sorting, but we can use this sort function. Okay, so this will sort the array or vector internally. Okay, now if I want to maximum of 2 numbers, I can use this max function. If I want to find the minimum of 2 numbers, I can use this minimum. Okay, so there are a lot of inbuilt functions in the algorithm file. So I have written this in my notes. So there are a lot of functions. Usually we don't use much of them. We normally use min, max. Okay, sorting, sort, we will use sort a lot of time. Okay, so there is upper bound, there is lower bound, so that we can use. Okay, so algorithm gives us some inbuilt functions or some inbuilt algorithms. So there are a lot of data structures in STL. We have used the most commonly used, and majority of the times we will use these only in our day-to-day problems. Okay, so there are multi-set, multi-map, which we rarely use. There is list, which we rarely used. Okay, so this was, even if you do these, this will be more than enough. Or if we require anyone other than this, we can Google. Okay, we can learn. So this is not a very huge thing. So this was all about C++ STL. We have discussed a lot of sorting algorithms, but one is remaining. Okay, so let's discuss that also.